All right. Hey, good morning, ladies and gentlemen. So, I'm not going to lie, I'm a little frustrated right now. This is the third time I've recorded this video, and it takes me such a long time. I've probably been working at this for an hour. For some reason, it's not working. So, this is the last attempt I'm going to make, and if it doesn't work, then I'll figure something else out for you guys. But um, I have no doubts that it's going to work this time for me. So, yesterday might have been a little confusing. Yesterday, we talked about how we can figure out the electron configuration of any element just by looking at the periodic table. For instance, let's practice. Let's work with, let's focus on carbon. Let's focus on carbon. So carbon sits right here, right? If we look at our periodic table, carbon is right here. It's element number 6. That means it has 6 electrons to balance out its 6 protons if we're going to talk about it being neutral. So, if we were to look at this, if we were to look at carbon, and of course it's right here, carbon is this element right here under the number 14, we're going to have to figure out what our electron configuration is. So first we look at our first floor and see what we fill up. Well, we fill up the 1s orbital, right? First floor, s block, or our s room, and then we have 2 electrons, so 1s2. And then we fill up the other one too, the second floor, right? Second floor, s suborbital, we fill that up, so 2s2. And then in this 2p suborbital, we fill up 1, 2. We only fill up 2. So it would be 1s2, 2s2, 2p2, right? That would be carbon. Now today I'm going to show you almost an even easier way to do this. And that is through this scary looking thing called an orbital diagram. And I promise this is very similar to your boarding house example. Think about it this way, right? Look here's my floor. Here's my first floor, right? Remember on the first floor we only had the S room in the boarding house? Well, the same thing for the atom, right? Here's our nucleus. This might as well be the kitchen. And then we have our small room, right? Our S floor, or our S room on the first floor. Then we go up to the second floor and we see we have, well, 2S, right? That's our second floor. S room, excuse me. And then we go to the other room in the second floor and we have 2p, right? And so on as we go up. And the way we read this, right, I want to talk about how we look at this. And our rules are the same as the boarding house. So our first rule is always going to be start at the lowest energy level. And all that means is we start closest to the nucleus, right? We see as we go up, energy increases. Same thing with a house. So we're always going to start with 1s1, or excuse me, we're always going to start with 1s, and then we're going to move up to 2s. And then we're going to move from 2s to 2p, because you see there's a little bit of an incline, right? 2p is higher than 2s. So our electrons are always going to want to fill up 2s before they move up to 2p. And then 2p to 3s, and then 3s to 3p. And then normally you'd think, oh, 3p to 3d. Well, this is why it was different yesterday. 3p actually goes to 4s because 4s is lower in energy than 3d is, just by a little bit. So then all of a sudden, our 4s, the electrons, if they fill up, they'll go to 3d. And then from 3d to 4p. And then from 4p to 5s, and so on. So that might seem a little confusing at first, and I don't blame you. But the easiest way to think about it is you start with the lowest one and you just keep moving up. Whatever is up next, up highest, across the whole entire thing, okay? So just keep moving up, almost like a ladder. Okay, cool. That's our first rule. Our second rule is this. Our second rule is only only 2 electrons fit in an orbital. Now what that means, right, these are like bunk beds. Remember the P rooms had 3 bunk beds, which 2 campers could fit in? Well, same thing here. There's 3 of these suborbitals in the subshells. There's 3 of these suborbitals in this 2p right here. So only 2 campers will fit in each. Same thing with the S rooms, right? There's 1 bunk bed, so only 2 electrons fit in there. So for each line, you're only going to have 2 electrons once we start filling these out. Next one is that electrons, like the campers, will always fill empty orbitals before pairing up. same room. And like I said, for that, what that means is if we have electrons here in this 2p, and you'll see an example of this, if we have electrons here in 2p, they're always going to go separate out. They're always going to do one here, and one here before they start pairing up. Whew. Sorry for the yawns. It's been a long morning trying to record this. So they're always going to want to separate out before they start pairing up. Just like our campers, right? We'd always fill up the bottom bunk before we put any campers on the top bunk. Same thing for electrons, right? We're always going to have one in each slot until we have no more room, in that P subshell, to go ahead and fit more campers. And then finally, this one won't make sense until we do our electron diagram that we're about to do, but electrons face different ways in a sub. So all that means is that if there are two electrons sharing a bed, the person on the bottom is going to lay with their head over here, and the other person on the top is going to lay with their head over here. Okay? So you just alternate, right? One faces that way, one faces that way on the bunk bed. And then we answer this. Which electrons are higher energy, near the top or near the bottom? Well, these bottom ones have the lowest energy, so that must mean the higher energy is all the way up here, right, with these guys. Cool. That was a little fast, but I promise it'll make sense once we do this page right here. And all I did is, you guys have a model right here. I just made this a little bit bigger. I recommend you do the same so you can see. So it says use the orbital diagram to create an orbital diagram for sulfur. So first we have to figure out how many electrons sulfur has, and luckily I already have the periodic table pulled up. And we see sulfur right here is element number 16. So in order for our atom to be neutral, 16 is our atomic number. That means there's 16 protons. We need our electrons to equal the number of protons. Easy enough, so that just means we have 16 electrons we have to put in. Let's go ahead and put these arrows in, right? When we do these, we represent electrons with these arrows because they face different ways, remember? Like I said, electrons, when they go into suborbitals, they have to face different ways. So, our rules are always fill the lowest energy first. So that means we have to start here with 1s. Okay, well, I'll throw this up-facing one in there. All right, cool. Now, where do I put the second one? Only 2 electrons can fit in an orbital. Okay, gotcha. Never pair up electrons unless there are no empty spots, and they face different ways. So I know I have to take in this one and put it here because there's no available spots on that energy level anymore. If I were to fit an electron without pairing up, I would have to move it up here, and that takes energy, and electrons don't want to do that, right? Electrons don't want to do that. So next we move on to 2s. Okay, 2s, we put one facing up. That's normal, and we put one facing down because there's no other room for them, right? Because it would take energy to move up to this 2p orbital. All right, here's where we're at so far. We've placed 1, 2, 3, 4 electrons, both facing different ways and both containing different amounts of energy. Now we can finally move up to this 2p suborbital. Okay, so I'll put my first one in, right? We've just been sticking with that. First one. But now all of a sudden I have a choice. I could put it in the next box over, right? It's the same energy level, or I could pair them up. But remember, our rule says never to pair them up unless there are no empty orbitals left. Okay, so that means I can go ahead and fill these empty ones up. Easy enough. And now I start pairing. Remembering they face opposite directions. So, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? We have 10 and we got 6 more to place. So the 3s is going to look exactly like all the other s sub shells, right? Just looks like the 2s and the 1s. Now we have 12 total and we have 4 more to place. Okay, so the 3p is going to be the same. We do an up and we make sure we don't pair them up until we absolutely have to. Now we have to, but how many electrons do I have? We have 2, 4, 6, 8, 10, 12, 13, 14, 15. So I only have 1 left, and that goes right there. Now that is totally fine. You can have these electrons here without a pair. They prefer it that way. That's why they fill up empty spaces before they start pairing up. So This right here is the orbital diagram for sulfur, right? Once we follow our rules, it's not too bad. Now, if we were to ask what the electron configuration is, that code, this is going to be even easier, I think, than what I taught you guys yesterday. So let's start here. It's just like in the boarding house. On the first floor, in the S room, how many campers do I have? 2, right? So it would be 1s2. Easy enough. In the second orbital, the S subshell, how many electrons do I have? 2, right? So it would be 2s2. On the second orbital, in the P subshell, how many electrons do I have? 2, 4, 6. So that would be 2p6. And then how many campers or electrons do I have on the third orbital, S subshell? That would be 3s2. And then finally, how many do we have in this 3p subshell? We have, well, it's going to be 3p, 1, 2, 3, 4. 3p4. Just like that. That's the electron configuration for sulfur. What steps did we use to figure out the electron configuration? Well, we filled this out. And then we just went up the ladder, right? 1s2, 2s2, 2p6, 3s2, 3p4. All right? Okay, so I'm going to have a little bit of practice for you guys to do. Hopefully this video works for me. It's basically going to be like 2 slides of what you did yesterday, okay? But starting from beginning to end, okay? All right, so if you guys have any questions, you can always message me on Schoology. If not, I will talk to you guys tomorrow.